2026 is the year code review finally has to catch up to code generation. AI tools let developers ship code 10x faster. We know this. Cursor, Claude Code, GitHub Copilot, all of these AI coding tools can write entire features in just minutes. But if your review process can't keep pace, speed is going to become a liability. Bugs will slip through and standards could potentially drift, and the code quality gaps will widen significantly. AI native engineering teams are rebuilding their code review process to scale at the speed of AI. I'm Naina, and today I'm breaking down 5 code review best practices every engineering team needs in 2026. We'll look at what tools are out there, where they work, where they don't, and how to build a review process that actually scales. Now let's get into it. Best practice number 1, catch issues as developers write code, not after they open a pull request. Here's the problem with some of these code review processes I'm seeing. They happen just a little bit too late. Code gets written, the developer moves on to the next task, and then someone flags an issue in the PR. Now it feels like rework, the context is gone, a lot of context switching, and fixing it can get a bit annoying. The best AI native engineering teams I'm seeing out there are shifting their code quality enforcement left. Their code review processes involve catching issues in their IDE or in the terminal before code ever reaches a pull request in GitHub. So what tools are actually doing this part? Linters like ESLint and SonarQube catch syntax issues and code smells, and they do it fast, but rule-based with no context. So they'll flag some pretty valid exceptions, yes, but that's a pretty limited scope of the type of issues that can be caught. AI coding assistants like Copilot and Cursor are best known for code generation and helping you write code faster. And then we have purpose-built AI code review tools like Qodo that analyze code with full codebase context, catching breaking changes and architectural drift and standard violations that linters just miss. Let me show you what that looks like in practice. You write a new feature and you need a local review. An automated code review tool is going to analyze your code change with full codebase context. It provides suggestions to improve and a one-click fix in your IDE before you even make a PR and before a team member ever gets to see it and review it. Centralize your coding standards and let them evolve with your code base automatically. Here's a problem I recently started talking about on social media, and that is your coding standards are scattered everywhere. Some rules live in linter configs, others are buried in docs somewhere or Slack threads. And then senior engineers might leave feedback in PR comments, and that becomes sort of tribal knowledge, but it never makes it into your official standards. So as your team scales, then this becomes impossible to maintain. And I've seen developers complain about this online. And think about new hires. They don't know what's expected. Rules can fall out of sync with reality or the current state of the code base and team conventions very, very quickly. And enforcing those standards becomes this manual, exhausting process. So how do you actually solve this? Traditionally, I've seen teams try a few things. Some use markdown files like Cursor Rules or agent.md. It's pretty manual, there's no real enforcement, and there's no real way to track compliance. And I've seen other teams rely on linter configs, which is great. It's great for syntax, but they can't handle architecture or context-specific decisions. What I think that teams actually need is a system that centralizes standards in one place, so it's easy to manage and migrate other standards into, whether it's from Cursor or Claude Code. They also need a system that discovers new rules automatically from how your team is actually working, and then enforcing those consistently across the team and the engineering organization. This system should also measure whether the rules and these standards are actually working. And that is exactly what you can do now with Qodo Rules. A few things to point out here. Qodo Rules is great because it's centralized rule management. All of your engineering org's rules are in one place. You can scope them org-wide, or by team, or by repo and project. So each rule includes description, examples, and severity levels, and it all just gets managed in this one place. There's also automatic rule discovery from PR comments. Now, this is the exciting part to me, is that Qodo can analyze your PR history and it finds patterns in engineers' feedback and then suggests rules automatically over time. So it essentially sees that your team keeps saying maybe a comment like add error handling for async calls. So the rule system is going to suggest, should we make this a rule? And you can approve it or deny it, and done. And if you approve it, now it's just enforced everywhere. Customers often tell us we don't have rules files. All of our rules are just buried in PR comments or in just so many different places, and it's really hard to manage and even find. This rule system in Qodo solves that. There are a few exciting features about this system, and that is the prompt to rule generation. You can write a rule in plain English and then, for example, enforce rate limiting on all API endpoints, something like that. Qodo's going to generate the logic and the code examples and the enforcement checks. And once you approve that, it just works. So it's a really easy rule generation process that you can do inside the portal. There's also the conflict and duplication detection capabilities that it has. So when you import or add rules, Qodo's going to flag the conflicts and any potential duplicates before it causes problems. And you get to review that and determine, oh, this is a duplicated rule. I can decide which one to reject and which one we're going to move forward with and approve. And one of the best things that it has is analytics and reporting. There are dashboards that show which rules are violated the most in code and in the code review process, where that's happening, and the trends over time. So this is actually a great way to prove to leadership that your code quality initiatives are actually working. When you have that visibility into which type of rules are potentially being violated and if any are getting merged into the main branch. I consider this rules management to be a first-class system in your development process. Best practice number 3, review code with full codebase context, not only the diff. A lot of different code review tools are popping up. They work really well at the diff level in GitHub. They can see what changed in a PR, but they don't understand how it fits into the rest of your code base. And I think that that's a real problem. Real issues aren't always in the diff. They're sometimes in the connections across the code base. Did you break a downstream service? Did you duplicate logic that already exists somewhere else? Does this change violate an architectural pattern that was established 6 months ago? Diff-level reviews are going to miss all of that. So let's talk about what deep context actually means. Deep context means the review system understands your entire code base. Multiple repos, dependencies, historical patterns. It's not just reading the 50 lines that you changed, it's reading the 50,000 lines that those changes interact with. Here's a real example. You refactor a utility function in your core services repo. A diff-level tool says, looks good, no obvious issues. They're only seeing the changed lines. But a context-aware system analyzes the entire code base, and it's going to run semantic analysis. It's going to check dependencies and flags and say, wait, this change breaks 3 downstream services. That is the kind of insight that is a lot more complex, yes, but a lot more valuable to a developer when you're leveraging a tool like this for code review. And that is the difference. One reviews what you wrote, the other reviews whether it's even safe to ship. And what's great is that this is what Qodo's context engine does. Multi-repo indexing and semantic analysis to catch issues that only appear when you understand the full picture. Best practice number 4, automate the entire review workflow. Getting AI-generated comments in your PR is helpful, but that's only half of the problem. The other half is that what do you do with this feedback once you get it? If every suggestion requires manual triage, copy-pasting code, running test, re-requesting review, you've just replaced one bottleneck with another, essentially. The best review systems actually automate the entire workflow, not just the analysis phase for code review. Here's what that looks like in practice. Traditional CI/CD tools run tests and checks, but they don't fix anything. They'll tell you what's broken, and then you have to fix it manually. Agentic review platforms like Qodo, these don't just flag issues, they're going to fix them as well, automatically. One-click remediation or fully automated using a skill if you trust the rule. Here's an example. If your PR violates a team standard, like missing error handling on an async call, an agentic tool is going to flag it, it's going to propose a fix, and then you can apply it and resolve the conversation. That is the difference between review feedback and actually tightening that feedback loop in a code review process. Best practice number 5. Track rule compliance and prove your review process is actually working. How can you really determine that your code review process is effective? Are developers following standards? Which rules are getting violated the most? And are violations going down over time, potentially? Without that data, you're pretty much flying blind. And without data, you can't really make the case to leadership that quality initiatives are worth investing in. So what should you measure? Well, I have that list for you. Rule compliance rates. Which standards are being followed? Which are being ignored? Violation trends over time. Are things getting better or are they getting worse? Hotspots by repo or team. Where are issues concentrated in your repo and across your code base? And then there's time to resolution. How long does it take to fix violations? Tools built for enterprise teams like Qodo, SonarQube, or internal BI dashboards, they're going to give you the data that you need to show leadership. Our code quality initiatives reduced violations by 40% in Q1. Here's the proof. So there you have it. 5 best practices for AI code review. Number 1, shift enforcement left by catching issues in the IDE or the terminal before you even make a PR. Number 2, manage your rules just like you would code, with discovery, analytics, and enforcement. Number 3, use deep context, not just reviewing the diff in GitHub. Number 4, automate workflows, not just the process of analyzing code review and receiving the feedback. And number 5, measure what's working. I wouldn't consider these best practices nice to haves, to be honest. I think that they're the foundation of code quality at scale on engineering teams. And if you're evaluating tools, you should look at some of these types of capabilities. If you want to see how we've built this at Qodo, especially the rules management piece, which honestly no one else is doing right now in this space, check the link in the description. We've got docs, demos, and a free trial for teams. If this was helpful, drop a like and subscribe, and see you in the next one. Thanks, everyone.